Last few people trickle in here to our presentation and webinar this afternoon, or for this morning for you on the West Coast. We'll get started, and certainly for those as they come in, they'll be able to catch up. So hello everyone. My name is Craig Haney, and I am the Director of Marketing here at Energent. I want to thank everyone for taking the time today to learn a little bit about monitoring and targeting for the manufacturing and the industrial sector, and how we can use M&T, or monitoring and targeting, for effective energy management in this very particular sector. So today we'll define some of the basic monitoring and targeting principles. We're going to provide some insight into the value of real-time data. We'll show you some examples about how other manufacturing facilities and how they're using monitoring and targeting to save money. And finally, we'll give you a brief overview of some of the ways companies are using incentives from utilities to fund these projects. If you have any questions during the presentation, please use the Questions tab to the right of your screen and just type your questions in there. We will save some time at the end of the presentation to answer any of the questions that you have, and hopefully we will be able to get to them all. The presentation will take about 30 minutes, and then we'll leave 15 minutes for questions that people will have asked throughout the webinar. The webinar is also recorded, and we will post it on the Energent website. So if you want to refer this webinar, if you want to refer to it at a later time, you're certainly able to do so, as well as you're able to forward the link to any colleagues or friends that may be interested in the topic, but were unable to attend today. So let's get started. I can tell you a little bit about who we are. Energent is an energy management firm based out of Waterloo, and really we're a team of energy experts that provide energy management software and services. So that includes monitoring and targeting and measurement and verification software for industrial, commercial, and institutional clients. Our software is hosted in the cloud, which provides faster installs and lower costs compared to some of the larger enterprise systems. We offer a software and a service model. And what that is that's class-leading energy management software and a team of energy analysts to support our clients to help act on these energy savings opportunities. At the basic level, we monitor real-time energy consumption, and we compare this to the mathematical models, which we're going to go through a lot today, and then we use that to highlight savings opportunities. We've been working with industrial clients for over 10 years, supporting various energy efficiency projects, and these projects have led to SciPec awards and millions of dollars, kilowatt hours, and meters cubed saved. So this 30-minute webinar will start with an overview of monitoring and targeting principles to ensure that we are all on the same page as I go through today's talk. I also want to spend a little bit of time talking about the value of real-time data. And in today's case, matching this real-time energy consumption and production data to a predictive model with the goals of lowering overall energy costs. I will go through a few important points about energy modeling to give everyone an understanding of how these complex models are built. From there, I will walk through some very successful case study with a customer from Ontario. I'll also briefly explain what the process and systems program is that's run through the Ontario Power Authority and their Save on Energy program, just as one example of some funding opportunities. And finally, we'll leave some time for questions at the end. So let's start by defining what monitoring and targeting is. So this slide comes from the Dollars to Cents workshop that Natural Resources Canada runs on a regular basis across the country. If you are interested in any of these Dollars to Cents workshops, please let us know and we're able to help facilitate setting one up for you. Monitoring and targeting is a process that can be defined in these two specific ways. First, it's a method to detect abnormal changes in energy performance, and this is designed to trigger corrective action to eliminate or reduce energy waste. Second half is it's a method to identify savings opportunities, and this is designed to understand periods of best performance and then try to make those periods repeatable. And as you can see from the quote below, monitoring and targeting takes the guesswork and assumptions out of the energy data and provides information and knowledge to support the decision-making process. So along with this definition, there are 5 principles of monitoring and targeting that are important to understand. Every good monitoring and targeting approach begins by understanding this basic principle. You cannot manage what you don't measure. This is true for a number of other management situations as well, but it is especially true for energy management because the data is right there and it's relatively easy to access. If you want to manage your electricity consumption, understanding how much you consume, when, and where is essential to a successful program. Measuring energy is relatively easy as there are well-defined metrics to use as part of a monitoring and targeting program. The important aspect for you is to ensure you understand what metrics are important for your organization and set the program to measure consumption against those metrics, for example, production data. If energy contribution per widget is important, then ensure you have all the information necessary for understanding how many kilowatt hours or meters cubed are consumed, how many widgets are being produced, and the total square footage of the building or warehouse you're operating in. If your organization's carbon footprint is an important impact, then understanding how carbon footprint is generated and measured, and then make sure you have the tools in place to achieve this metric. Another aspect of measurement that is important is consistency. The more data that is incorporated into a monitoring and targeting system, the more accurate it becomes. As with any modeling exercise, a larger sample size increases the ability to predict patterns. If you have access to real-time production data, different line outputs, etc., including them into the model increases the visibility into the contribution energy has on overall production costs. To be relevant, real-time information must be compared to an accurate baseline to ensure that we're comparing apples to apples. This baseline provides context. Maybe one month we see our electricity bill rise, but without some context or that mathematical model, we don't know if that's because it's warmer outside or because plant operations are less efficient. A baseline is this mathematical representation of your energy consumption. We don't know how efficient you are operating until we can include data that affects energy consumption. Weather, production schedules, and throughput are often important drivers for manufacturers to truly understand their energy consumption. And we'll go into this in more detail a little bit later on. So monitor this information closely and consistently. A monitoring and targeting program is most useful when engaged energy managers or operation personnel are searching for opportunities. If these people aren't using the system, unfortunately, it won't create savings on its own. Many have heard that putting in a monitoring system in place can save a certain percentage. 5% is often cited. Although this may be true, it still takes user engagement to identify these opportunities. Monitoring and targeting is the system that can enable incredible energy savings if these opportunities are acted upon. And finally, that leads very well into my last point about acting. Monitoring and targeting programs are the enabler for change. They can quantify, categorize, track, and verify energy savings in every area of your operations. The best savings programs are the ones that are engaged energy managers act on the alerts that are driven from the system. If there is an overconsumption alert, energy managers need to investigate the cause of that alert and, applicable, act on that to reduce the energy waste and save money. Once these savings events have been quantified, begin reporting on these events to share within your organization to build confidence in the system and cultural buy-in to continually improve the overall energy performance of your facility. One of the benefits of all this connectivity we have is access to tremendous amounts of data. One of the challenges of this connectivity is this tremendous data we have access to. What are we supposed to do with all this data? It isn't useful unless it has context and is presented in a meaningful way. Specifically, how are we going to help to turn this mountain of energy, production, weather data, and occupancy data into useful information, and then ultimately knowledge we can act on? Real-time data enables this transition from data to information to knowledge. Having access to this data quickly and at a level that enables action provides that opportunity to see how subtle changes in operations can affect energy consumption. Alerting users when energy consumption is much higher or lower than expected is an important aspect of any M&T system. The important aspect that enables knowledge is to have these alerts based on consumption that is over the predicted level. That way, the system that is normalizing for weather and production which are often the main culprits of these false alarms. Understanding which projects generate the biggest savings creates an opportunity to build business cases for future projects. Real data provides confidence and buy-in from all stakeholders, improving the ability to do future energy-saving projects. Finally, making all this data easy to access from one central location provides access to all levels of the organization in ways that are meaningful to them. In many cases, energy data and production data are in different systems, making it impossible to analyze the relationship and identify savings opportunities. Excuse me. Creating an energy model is a combination of science and art. The science is understanding the correct relationships using historical data and correlated manufacturing data. The art comes in when the modeling expert begins to tweak the model to better represent the true energy profile of the facility. To begin, understand which commodity or commodities are the largest contributors to the energy cost of the operations. This is usually well known by plant operations. Second, begin to meter and measure each of these commodities separately. In some cases, your facility will have some sub-metering in place, but in many cases, they will not. This is a very good time to engage with your utility to see if there are any programs in place to better meter your facility. Next, or ideally at the same time, measure and record production information. For most manufacturing facilities, the challenge will be to ensure the production data is easily available, especially to share with other information systems. After the measurements have been taken place, understanding the drivers of energy consumption will drive the model development. The drivers will often be weather, production output, type of material, possibly which shift or line the production is occurring at, and a variety of other aspects of production that drive energy consumption. The modeling engineer will work to understand the relevance of each driver and whether to include it in the model or not. This is where the modeling industrial processes are very different than commercial buildings. In principle, they're supposed to be the same, but in reality, they're very different. Commercial models may require two drivers, weather and occupancy being the two most common. Industrial models, though, we could have up to 9 different drivers, including production mix, product throughput, and other aspects of manufacturing processes that drive energy consumption. Your manufacturing processes deserve an industrial strength model. The final step in creating the model is to bring all this data together and build an algorithm that closely represents the energy profile of your production facility normalized for these energy drivers. Once this model is created, using international standards like IPMVP or a coefficient of variation, we'll evaluate the strength of the model, or, in other words, tell you how closely it represents the actual energy consumption of the facility. So I want to go through a few screenshots. It is from our system, but to show you how the model and the consumption information can be represented in graphical form. So the energy drivers chart is a visual representation of each driver's contribution to the energy model. In this example, the type of product they creates an impact in the energy profile and the difference amounts which are shown in the smaller pieces at the top, ranging from 2 to 9%. The baseload contributes about 38% of the energy profile, meaning that to operate the plant, lighting and cooling, etc., it contributes most to the energy profile. This allows us to quantify how much a lighting project could save them. For example, if a lighting retrofit includes installing T5 bulbs, it would reduce the electricity used for lighting by 25%. But it's 25% of the 38% baseload, meaning that they can reduce overall electricity by approximately 10%. Understanding this relationship greatly increases the accuracy of savings projections for all projects. The control chart is a configurable tool that helps understand when alerts would be generated for users of the M&T system. The green, blue, and red lines represent thresholds of over or under consumption based on the predictive model. In this example, if consumption values are 35% above the predicted value, a questionable high alert will be generated. If consumption is 25% above the predicted value, an overusage alert will be sent to the system user. This control significantly reduces false alarms and encourages users to be very attentive of the consumption's alert and ultimately acting upon them. In this consumption chart, the actual energy consumption, which is represented by the red line, is compared to the model value, or the blue line. In this example, you can see the 5-day-a-week schedule is generally followed, but there are two significant consumption anomalies as compared to the model, and those are highlighted there. The Q-sum chart shows the long-term savings or energy wasting trends. Q-sum is the cumulative sum of difference between the predicted energy consumption, or the model, and the actual consumption. If the user is consistently under-consuming, meaning they're saving, then the Q-sum will go down and to the right. Overconsumption based on what the predicted level says is shown by moving up and to the right. A steeper slope means a bigger impact. In this example, there is a long savings trend for the first half of the time period, but there's a switch in operations and we see a leveling off of the Q-sum and a slight rise. In this scenario, energy analysts could work with the clients to understand the cause of the shift and try to get the client back up on the savings trend. The energy variance chart is a quick view of how consumption is compared to the model. This model is represented by the horizontal x-axis, and any variations above or below that predicted model are shown in red or green. So the next series of slides will explain a case study with a Stratford, Ontario auto parts manufacturing customer. This study highlights the strength of real-time monitoring and accurate modeling to build a business case for improving operations and investing in capital projects. This project occurred through 2008-2009 and saved the company $250,000 in the first year after the system was deployed. With the help from Union Gas, we created a plan to investigate how an energy management system could help Gates understand their natural gas use and how to lower energy consumption and improve profits during the last economic downturn. As we all know, Ontario manufacturing has been hit very hard since 2008, as has the entire Canadian economy. So, in 2008, when both Ontario manufacturing and Canadian economy hit the bottom, manufacturers had a choice to make. Would they cut all costs and just try to ride out the downturn, or would they strategically invest and look for partners to help better weather this economic climate and also future downturns? So Gates turned to Union Gas to better understand how they could lower their energy costs, and Union Gas turned to Energent to use real-time information to help achieve steep conservation targets. Together, all three companies worked together for the common goal of lowering overall energy costs for this company. So Gates is a leading supplier of highly engineered powertrain parts in Stratford, Ontario. During the 2008 economic downturn, Gates looked everywhere to try to lower energy costs to boost profits and manage this drop in demand. So Gates turned to Union Gas to help sponsor a project to provide visibility into their energy use through increased submetering and installing a real-time energy management system. The goal of the program was to provide real-time feedback to lower energy costs, improve operations, and ultimately survive this challenging economic climate. The situation was that Gates had to make a difficult decision of moving from a 7-day production schedule to a 5-day production schedule. A portion of their furnace was kept idling at full temperature during the weekend, as they are relatively difficult to restart and bring up to full temperature after being shut down. The question they wanted answered was, could natural gas savings make a full furnace shutdown worthwhile? Although there are many other pressing operational issues needed to improve the overall efficiency of plant operations, this was the first question that needed to be answered to build the confidence in the system and to achieve real savings. The monthly natural gas bills did not provide enough visibility to accurately and confidently state that there was a strong business case to shutting down the furnaces over the weekend. To ensure that all levels of the organization bought into the program, a project approach was developed by a steering committee containing people from all three organizations, Gates, Union Gas, and Energent. So step one in the process was to install a real-time energy management system. This system, our system, would provide them with a few key pieces of information to ensure success in the project. First, it would provide accurate natural gas consumption in 5-minute intervals at each of the metering points. This gave them increasing consumption visibility they needed to make good decisions. Secondly, it gave Union Gas the information they needed to choose the locations of 13 additional submeters in the plant. These submeters were put in place to compare consumption of each of the furnaces, as well as other areas that were key to overall operational excellence. Once all the submeters were installed, Energent began to research the energy drivers that impact energy consumption. Using this increased visibility, Energent was able to create 4 different energy models that provided target values for energy use that is adjusted for those key energy drivers that we spoke about earlier. Finally, once everything was installed and monitored, Energent began measuring the energy consumption in 5-minute intervals, comparing these values to the 4 models that have been created, and in real time providing plant personnel timely feedback as to whether energy consumption was above or below expected values. It also provided the opportunity for operators to experiment with different equipment and operating practices so they got the very best energy performance. Very quickly, it was evident to the team that it was easy to make the business case to modify operations and turn off the furnace over the weekend. So financially, here was the impact. Natural gas was reduced by 8.2%, electricity was reduced by 12.3%, a return on investment was generated of 150%, and the resultant payback was less than 8 months. Overall, it provided $20,000 a month in savings, or $240,000 annually. These are real savings that the executive team and the operations team understood and did not affect the throughput of the plant at all. Beyond the first year of savings, this project has had lasting impact on how operations are now being run. Plant operations were now able to adjust furnace settings and see the impact almost immediately. They were able to improve the sequencing of compressor units to match demand instead of just ease of operation. They were able to build a business case ahead of any major purchases, providing an estimated return on investment for all capital projects, giving management the information they needed to confidently present to the executive team. Priority scheduling was created to utilize the most efficient equipment first and look to only use the less efficient equipment if necessary. Finally, a green team was developed out of this that now created many more sets of eyes and ears to identify opportunities for energy savings, ultimately creating a culture of conservation. Certainly, we are happy with the success of this project and how our system was able to increase profits and help Gates weather that very difficult economic period and come out the other side a leaner organization. Now, Gates was able to access funding for this project through their close relationship with Union Gas. There are opportunities to access funding for many different utilities. Because we're a little tight on time on this presentation today, I will highlight one opportunity in Ontario to access funding for this type of project. The Save on Energy program that has been set up by the Ontario Power Authority has been the face of energy conservation initiatives in this province for the past few years. Embedded in the Save on Energy program is the process and systems plan that encourages large industrial energy users to invest in long-term energy savings projects and provide significant funding for these initiatives. These include capital projects, embedding an energy manager into an organization that does not already have one, commissioning engineering studies to project savings, and installing a monitoring and targeting system to validate these savings and ensure these savings are sustained for many years to come. The incentives are significant as funding is available for up to 70% of eligible costs up to $75,000. These programs are run through your local distribution utility, and Energent can help any Ontario-based industries apply and qualify for these. In fact, we're running a webinar on industrial energy conservation initiatives from coast to coast coming up on June 28th. So just as a side, there was an interesting announcement from the provincial energy minister here in Ontario, Chris Bentley, on Tuesday of this week, and it has lots to do with industrial and electricity spends. So I'm going to summarize the press release, and this is quoting from the press release, so please excuse any partisanship. It is not from myself. So large industries looking to expand or set up shop in Ontario will be able to qualify for lower electricity prices starting next year, Energy Minister Chris Bentley announced Tuesday. Eligible companies could qualify for a reduced electricity rate if they create new jobs and bring new investment into Ontario. The connection between jobs and the incentive is at the heart of the program, Bentley told reporters. They have to create extra jobs, and the incentive only lasts as long as the extra jobs last. It's not a new industrial hydro weight for all companies to stop firms from leaving neighborhood jurisdictions with lower energy prices. Instead, companies that make a minimum investment of $250 million will be eligible for long-term contracts at the wholesale market price, which is a reduction of about 30% from current rates. So that's the end of the summary of the press release. So obviously there are a lot of questions that come out of an announcement like this, of a new program. It's clearly not well defined, but overall it's a recognition that industry is really looking for some help with energy costs. Now, saying that, a kilowatt hour conserved or a kilowatt reduced is still the cheapest form of energy. So to summarize, we went through the 5 monitoring and targeting principles of measure and manage, collect and analyze, compare, monitor, and act. By following these 5 principles, your energy management plan will have the greatest chance of success. Real-time monitoring and targeting is an essential tool to ensure the programs and energy conservation measures are achieving the targets that are set for them. We explored the importance of strong modeling and ensuring that your energy models accurately predict your energy use and that the model is robust enough to handle all of the drivers present in an industrial setting. Finally, we need to ensure that the models, the consumption data, and the reports are delivered in such a way that allow users to act on these opportunities quickly. We showed energy driver charts, control charts, and QSUM graphs, as these are all important tools for energy managers to take advantage of. Secondly, we noticed that in our case study presented, there was a consistent theme to ensure a successful energy management program. These were create an energy management plan, need to monitoring and targeting, a thorough data analysis to find these opportunities. We need to measure these opportunities, and finally, we need to execute on them on the ones that have been identified. We also shared some brief information about the OPA Save on Energy incentive program that is available for some Ontario manufacturers. So of interest, we have 2 more educational webinars coming up this summer that may have interest to our industrial audience here. The first webinar is on June 28th, and this is a leveraging industrial incentive program to help go from BC to the Maritimes. It's a great webinar for anyone looking to execute on energy efficiency projects and are looking for funding to help. The second one is on August 16th, and there'll be a number of case studies for manufacturing industrial companies that have been successful in implementing energy-saving projects. You will definitely gain insight on how you can successfully implement some of these easy projects at your facility. You can sign up directly on our website under the News and Events tab. Just really quickly, here's a small sample size of some of our industrial and manufacturing clients. We began our energy management business working with General Motors many years ago, and we have built our system to be industrial strength. We have been a trusted partner for many years and are the first choice when it comes to industrial energy management information systems. So I wanted to thank you for taking the time today to participate in today's webinar. We'll now take some time to answer some of the questions that we've had during the presentation. So there's one question here with respect to the modeling and getting some of the historical data. So it's how much data do we need to understand that process or understand how to get that data from? So the answer is we like to have as much data as possible. So if we have a year's worth of production data and weather data and other information, that's great. If we have 2 years, that's wonderful. Normally we like to have a couple of different production cycles to make sure that we understand how a plant may operate in different circumstances. So we can usually collect that information either through a plant historian or we can work with utilities to grab that information. We have a question here about, I can answer this one really quickly. So is this presentation available? Yes, so it will be available on our website. In usually a day or so, we'll get it up either by tomorrow. It should be available on our website. And yes, we can. So one question here is: does Energents supply the historical weather data for the site? The answer is yes. We can collect that information from Environment Canada, and we grab that information and put it in together with the models. And then depending on the situation, we can even add a weather station moving forward in the facility to make sure that we're gathering as accurate weather data as possible. How long did it take to develop the predictive model for the case study for Gates? The gathering of the information and the creation of the model took about 6 weeks to develop. Once we were able to collect that information and then analyze the drivers, there was a few site visits to make sure that we understood what the production was and the equipment that was there. But once we did have that information, you're looking at about that long to get the predictive models. They had good information, so it was easy to grab the historical data to create those predictive models. Are there any other questions? Oh, how much did the submetering cost for the case study? I don't have that information. That was through Union Gas, so I'm not sure of exactly how much that cost. That would be dealt with through the local utility. So I just don't have that information. How do we charge clients? So typically in our situation, there's an installation fee, and then depending on the type of production and the number of models and the number of points that we're metering, we do a monthly service fee. So that software as a service becomes like a monthly fee, and then you don't have to worry about big upfront costs. There's just a small installation fee, and then usually a monthly charge based on the number of meters and the number of models that we're creating for our clients. Okay, well, I think if there are no other questions, I want to thank everyone again for taking the time to participate in today's webinar. I hope you found it very valuable. I hope you learned something from it. The webinar will be posted on our website, so check back in there to the past webinars. And then also please join us on June 28th for our Leveraging the Incentive Programs that you would find very valuable as well. Okay, so thank you very much for attending today's webinar.